So far we've looked at circular motion at a constant speed, which has a centripetal acceleration associated with this motion. So what if the speed changes as well? We can describe the motion of an object along a circular path using rotational kinematics. All of the same terms and definitions that we used in one-dimensional motion apply here. They are also still vector quantities, which will either point in the direction that the object moves or in the opposite direction if, for example, the object decelerates. Of course, this direction depends on where the object is around the path. So the best way to describe this is to say that the directions will be tangent to the path. This is convenient since centripetal motion points towards the center. It will always be perpendicular to the kinematic quantities, so we can think of these independently, the way we did with projectile motion. Now, rather than using x and y coordinates, we can uniquely identify the position of an object using the angle theta. Theta ranges from 0 to 2 pi radians. Changes in position, or angular displacements, are given by changes in the angle theta. Angular speed, which is defined as the angular displacement over time, is going to be a little different from the velocity we are used to. Here, the units will be radians per second. We use the Greek letter omega for angular speed. This is also sometimes professionally called squiggly w. Finally, we can define an angular acceleration as the change in angular speed with time. The Greek letter alpha is used here. Rotational kinematics are very analogous to the one-dimensional motion along a straight line. The important thing to notice is that we are not changing the structure of these definitions, just reshaping them in a way that makes sense for the circular path. This means that all the same kinematic equations apply. We just need to swap in our new symbols for the angular quantities. And just like one-dimensional motion, we can define positive and negative directions to help with the vector aspect. In this case, we will define counterclockwise as the positive direction and clockwise is then the negative direction.